Hi, and welcome back to the second half of the episode. We're here with Mike talking all about containers. So let's jump straight back into it. Dedicated pools, container architectures. Even with a fully managed service, there's going to be some sort of architecture and designing to be done. It's not just throwing things out there into a field and they just do their thing and grow and work seamlessly. In terms of being able to sort of tune and maximize the benefits for your specific use case, talk to me about dedicated pools and how they sort of manifest in that area.
So for us, we use dedicated pools predominantly for applications that require different hardware to run the workload.
So can I, I'll backtrack. My apologies. Explain to us what a dedicated pool actually is.
It's a Kubernetes, within the Kubernetes cluster, it is a separate pool of resources that are outside of, have their own deployment mechanisms and the boundaries, so that they don't, the other pieces of that cluster don't necessarily play inside that space. It's like your own sandbox inside of that cluster, if you will.
Okay, so you've got like all your hardware of your infrastructure. This group of hardware is sort of put into a dedicated pool that no one else can use it. That's what you're going to focus on there.
Yes, exactly.
Okay, awesome. Yeah, sorry. So in terms of the benefits in tuning, how have you used these dedicated pools and why are they a mechanism or an answer to one of the problems?
So in our general use case, a particular instance family, for us, the M5 instance family tends to run most of our generic workloads really well. And so we can run containers on top of that underlying infrastructure for the broad sense of our use cases. And then we have certain workloads that are more CPU dependent and memory dependent. And so we'll run a different instance family inside of its own dedicated pool that serves that workload to the best of our ability and facilitates running it more effectively, both from a cost perspective and performance.
Gotcha. For the viewers, the M series of instance, that's an AWS instance that has, for generic workloads, has a sort of medium mix of CPU to memory. Obviously, high memory families will have more memory in terms of the CPU to memory ratio. So in terms of what you're doing there, Mike, you're really looking at the workload and saying, okay, this workload will have multiple containers and it requires a lot more compute, or these 5 workloads all need a higher compute ratio than memory, so we'll make a compute heavy pool, and that's where they sort of run. Is that the correct interpretation?
Yes, and we try to limit the amount that we do that, right? Because it does add some overhead to manage that, because now there's more kind of moving parts in the system. One of the things that we saw with that was when we did our initial migration, we picked a particular instance type because we thought, oh, that's going to work perfect. And then it was really expensive. And we looked at that instance type and went, wow, this really is terrible. And so the team that owns running the services in that pool did a bake-off and said, okay, well, what's the best thing that we could run? And them doing that work didn't influence or affect any of the other pools that are running in the environment. They were able to do that kind of in their own private space without an impact to other services. And by doing that, they were able to shave a pretty significant amount of money off of what it cost us to run that platform on a monthly basis.
The phrase bake-off, one of the toughest challenges, I used to always get asked this, how do I know exactly? You look at the number of instances that are available, and there is literally tens of thousands of different combinations that you can have. There's a huge amount of variance. You look at multiple service providers. The question is always, well, which is the best one for me? How do I pick it? And the sort of default answer is, well, you've got to basically build it and run it on all of them. Is containers a way to sort of that bake-off really make that an efficient process to be able to compare these different sort of hardware types underlying, because they are a lot more portable. You can try this CPU memory ratio, then this one, then this one. You can do them in parallel. It's a really easy way to solve that problem of what would this run on different hardware? How would it perform? Is that something that would provide?
It provided it. I mean, I think the pool structure provided us with that ability to do the testing with less effort, right? We also have this functionality where we can split the workload across two different types of instances within that same pool. So you can run them simultaneously and see what happens when you run the same workloads against the same things in the same pool, but one is a different processor family, right? So we were able to get that we were able to vet that very quickly.
Okay, so you can actually run the different hardware types in the same pool and actually get the data within that one pool as well.
Yep. We've been doing that with Graviton recently, which has been pretty interesting.
Yeah, nice. What about things like the sort of burstable instance types that will, give you additional resources and then quiet down? Have you been looking to use those sorts of families of instances and VMs?
We use those in other parts of our business that are more traditional kind of VM landscape. We don't use those as much in the container space. Our workloads tend to be fairly static, so we're not looking for bursty instance types to kind of deal with our particular load. What we have been doing that's kind of analogous in some regard to what you're asking is play more in the space of auto scaling. So using auto scaling as that mechanism by which to deal with that burst or that increase in request rate and then scale back down once we've kind of finished with whatever that thing is that drove more traffic or drove more load to the environment.
Yeah, and sort of going back to what we said before in terms of around, putting different instance types into the mix, you can try that. So you're effectively, different pools allows you to use different CPU memory ratios. In effect, you're sort of being able to right size by the sounds of things a little bit easier because you can really get the right particular hardware combo. Is container also sort of helping right sizing because they can sort of, containers can move about a little bit. You've got that agility. Is it easier to right size because then you're sort of not taking a workload off a resource, but you're like taking a resource from a pool? Is that something in terms of right sizing? It helps right sizing because you can sort of have a bit more control over resourcing because there is a pool type of situation?
I mean, it allows you to flex what you have running in that pool if you're utilizing auto scaling. When you deploy containers, you're deploying kind of a static workload. So you're saying, I need some number of CPU units and I need some amount of memory. So that at a deploy time, if you just did a standard deploy, you're going to get those resources and you're going to keep them until you say otherwise. With auto scaling, you can change that and you can say, well, this is what I want my minimum to be and this is what the maximum should be. And then it'll keep it within that range based on the utilization of the resources within that cluster.
And correct me if I'm wrong, but that could then be used to provide auto scaling functionality for a workload that may not be sort of easy to apply auto scaling to?
Yes and no.
I read that wrong.
Yes and no. In theory, it should, but what we found is with certain workloads, in particular Kafka is one where we've seen that we need to be more pragmatic about how we scale up and scale down, where Kafka lag starts to show up in a particular pod, and then we need to scale that up, and the scaler will go, okay, I scaled up, and the CPU is no longer pegged, and then start to scale down, but there's lag that still is running, right? And so now you're in the situation where the auto scaler is going to take you up and down and cause an incident because it's basically thrashing.
So you've almost got like that hysteresis, like feedback loop just doing itself. Is there a way to sort of even that out or put in some sort of limits and pauses, delays between? Can you filter that out, or it's still a bit of a gap in the technology at the moment?
We wrote our own auto scaler. Go figure. And so we've actually written 3 different auto scalers inside of New Relic at this point, because we have 3 different workloads that all had some very specific requirements about how they need to scale and what are the metrics that they care about that they want to use to say, this is a thing that triggers a scaling event, or this is a thing that triggers a scale down event. And some of that is time, some of it is CPU utilization, some of it's in in the Kafka case, it's the lag, right? Like let's watch the lag and not scale down until the lag has been burned down, and then we can scale down. So that's a simple example there. But we have other services that need a different metric or
so before we jump, I want to jump into auto scaling a little bit deeper specifically. But just before we do that, we want to throw to the quick mailbag segment. This is where we read the questions and the feedback that you have with us. So again, if you have any questions or feedback, please feel free to reach out to us at feedback@finopsfridays.com. So over to the mailbag. All right, and welcome to the mailbag. This is a mailbag for the previous week's episode where we had Udam on talking about software as a service. If you'd like to ask any questions or give any feedback, feel free to reach out to us at feedback@finopsfridays.com. If you're watching on YouTube, you can also throw a comment down below. So on to the questions. How much data or information do I need for FinOps for SaaS? As Udam said, really look for the minimum required to do your job and start to build on that over time. So really start with the basics of doing maybe some allocation and some visibility, and then start to go a little bit deeper over time. And it really is going to be dependent upon what you're actually doing with the SaaS, how valuable, what component of your spend is that SaaS component going to be currently and also projected in the future possibly. If it's a really small amount of spend, you probably don't want to be doing a huge amount of work with it. So sort of keep in mind, effort versus reward. Also think about how you're going to automate with it. If they give you a heap of really easy to use data that can be ingested, processed, and work with, then that's going to be great. You're not going to be worried about having a large amount of data. If it's a small amount that's very difficult to work with and requires a significant amount of effort, you're probably going to have to take a different approach with that. So really think about, as I said, the long-term effort and reward of that. Should I use a FinOps SaaS approach for my internal teams? i.e., I currently provide mail services to my organization. Should I take a SaaS approach? They're basically on-prem here. The answer is yes, start to do that. That is a great way to start to build up some muscle memory about, if you do potentially move to a cloud-based, SaaS-based approach, that you can have to be doing the same sort of processes. So building up the memory around those processes now, getting up to speed and doing those sooner rather than later is a great way to get prepared and build capability there. It's also going to help you when you start to evaluate these SaaS services and migrate to them. You're going to be able to ask the right questions. You're going to have the data. You're going to have that capability to say, well, show us how you do this. How do you execute that with your particular offering? So absolutely doing that. A lot of people take a sort of cloud-based approach with their infrastructure. Things like recharge, they'll add a basic VM, add all the security and add all the common services and give that out with an uptake on a fee. Doing that for software internally and services as well would be a great way to build up those capabilities. What should my SaaS providers provide in terms of FinOps data or information? And how do I know if they're giving me enough information or I need more? We sort of spoke about this, and I think JR actually spoke about it as well in a video shout out about getting some standardization. Until we have a complete answer, I don't think there's a magical answer, which is a complete list. I would start to look at, what does the cloud provide? Because the cloud has had these challenges and there's been an enormous focus around FinOps and cloud financial management in the cloud. Well, what are the things that cloud providers provide? Things like billing, things like tagging. Look to see the features that they have in the cloud and whether or not the SaaS solutions provide those. My completely biased favorite, of course, the well-architected framework. Go through all the best practices and, can I do this best practice, or how can I execute and implement this best practice with the particular SaaS solution that you're looking for? Can you achieve it? Can you implement that best practice? Of course, the FinOps Foundation as well, look at the documentation they have, look at the challenges and how you would solve the challenges that they're addressing. If FinOps doesn't have an answer, they typically have a working group. What is the challenge the working group is working on? And then go back to the vendor of the SaaS solution and say, well, how do you provide this and how do you solve this problem? And really put it back on the vendor. It's the vendor is trying to provide you a solution. It has to be a complete solution and also help them understand that they need to be coming to the party and it's part of the requirements. It's not a nice to have. this is a requirement of a SaaS solution in 20 insert year here that we need to be able to do. And if it doesn't meet the requirements, well, what happens when you buy a solution or a service that doesn't meet your requirements? How do you typically address that? Address this the same way. Where do I start with SaaS in terms of FinOps? I think the outcome with everything needs to go towards that unit economics, that efficiency. What is my cost of an actual outcome? So that's going to be your direction. That's going to be your vision. So plot that out and start to look at the steps to get closer to that. As Zudan mentioned, start very simple. What is my usage? What is my cost? Very high level, and then start to iterate, start to go deeper down on both of those in terms of usage, looking at the types of usage, looking at the granularity. Even if you may not be able to change your costs if you change your usage, it's a good idea to have an understanding, because then you're really understanding the value of the application. You can't half your use, you can't half your costs if you half your usage, but maybe next year or maybe the year after, there is a solution that enables you to do that. So definitely understand, you want to be able to answer the question exactly how much value and know the value that is providing to your organization. So that's the mailbag for this week. As I mentioned at the start, if you have any questions, feedback@finopsfridays.com. Also, if you're watching on YouTube, so throw some comments down below. Back to the show. All right, and welcome back from the mailbag. So my apologies, Mike. I want to go deep into auto-scaling just before we sort of wrap up and finish. So just stepping back a little bit, how do containers actually scale in terms of, resources, CPU, memory, disk storage, all of that? How do containers actually scale?
So for us, we use a CPU requirement, and how much CPU do we need, which is and then how much memory do we need per instance? Like, do we want to have 15 containers running with this much memory and this much CPU, and then it will allocate that for your workload. And then with the autoscaler, you can add a layer on top of that says, what's my minimum size of, like, to run my workload at a minimum, what do I need? And to run my workload at a maximum, what do I need? And then it'll keep it in between those two, kind of your high water, low water marks, if you will, based on what the request rate is or whatever the CPU utilization is. And in most cases, it's the CPU utilization.
Yeah, is there a different time when you use one approach versus the other, or is it always just default CPU? If that starts to cause you concerns with that workload, then you sort of look elsewhere.
In the typical autoscaler that comes with Kubernetes, it looks at the CPU. But for us, we needed more than just CPU as a metric, because it didn't really solve all the problems we were trying to solve with autoscaling. And in order to enable that, we had to augment the autoscaler to allow it to pay attention to those other metrics that we were interested in.
So this is that sort of application scaling approach where you need to have more awareness of what the application is doing versus just the CPU.
And we've tried to write them so that it's kind of agnostic from an application perspective, but more workload related. So if it's a streaming type of service, the streaming services have typical behaviors and patterns that for their scaling up or down. And so we've written a scaler for streaming applications. We've written a scaler for a very particular, we wrote our own database. So our database runs in a particular way, so that autoscaler for that particular piece of our infrastructure is designed for those workloads. And then we have one for Kafka, because we have a lot of Kafka inside of our environment, and that the ability for clients to pay attention to that and know the right time to scale up or to scale down was the other factor that we considered.
And this doesn't sound like a unique problem in containers. Like if you're scaling behind, an application load balancer or something like that, for any workload, you'd have these potential same traps and tricks, right?
Yes, definitely.
Okay, then the gap is really the full suite of scaling functions from containers is sort of lacking at the moment. Would that be a fair assessment?
Yes, it's still a relatively new piece of the puzzle, and there are some interesting bugs that that live inside there. I guess the RP dragons. So be careful.
Gotcha. Excellent. And what was the sort of key thing you saw that, that the CPU scaling approach wasn't working? Like, what are we seeing here? Hey, we've got a problem. We need to switch to an application. How did you identify that was the case, and when was the right time to move?
So we had applications around particular applications that chose to go to auto-scaling early, and they used the built-in autoscaler, and what it looked like for them was they would have incidents where they would have an outage or some kind of a downtime that was the result of that thrashing that the autoscaler would do, specifically around Kafka.
Okay, so it wasn't as though they couldn't scale soon enough. They were scaling, but then they'd stop scaling. They would sort of do that back and forth thing.
Exactly. And so,
Gotcha.
So when that happened, that team was like, pause, right? Like, we're not going to do that. We're going to wait. And then my team came in and we were like, okay, so why aren't you doing auto scaling? Like, how can we help you get this to happen? Because we see an opportunity to save money here. And they said, well, it's this. And we went, oh, okay, we'll go write it for you. And so we wrote that for them.
Now, you went and just wrote an autoscaler. Is that an enormous task that requires very good devs, or is it a quick, simple script that any dev or cloud engineer could do? What's the sort of scale of complexity? If you give us a ballpark, like, is that something that any organization, if they have some cloud engineers, could tackle? Or is that going to be like building a whole program? You need to be an application developer to do that.
You need to be a developer to do it. It's not a script. And I have the luxury of having some pretty senior engineers that work with my team, and embedded engineers from our staff engineering organization, which are typically principal engineers that were able to come in and do that work and kind of do the heavy lifting, and then kind of step aside and let the organization run with it.
Gotcha.
But the other teams that have done auto scaling have dedicated teams of SREs that have done that work to write the code and actually like do all the testing and make sure that they have a thing that meets their needs.
Yeah, yep, understand. Awesome. Well, thank you very much, Mike. That's a wrap for the second half and for this episode in its entirety. Much appreciated, Mike, for coming on and taking us on board and taking us through containers. Again, if anyone has any questions or feedback, please feel free to reach out to us at feedback@finopsfridays.com, and we'll address it in the mailbag in the next segment. So thanks very much for your time. I hope you enjoyed the show.